Problem 627 asks us to, again, find the z-score for a particular area under the curve. Let's look at A. Find the standard normal z-value so that the area that lies to the right of z is 0.2119. As we look at this problem, we need to determine or have an idea where z is. Okay, so I know that 50% of the data is to the left of 0 and 50% of the data is to the right of 0. 0.2119, we're looking at 21% of the data. What they're saying is 21.19% of the data needs to be to the right of z. So that means that z has to be on the right side of 0. Z has to be positive in this case, because if it's to the left, then if it's to the left of 0, if it were over here, for example, that would mean that that would be more than 50% of the data would be to the right of z. They're saying that 21.19% of the data has to be to the right of the z value. So that's how I know that the value or the z value has to be a positive value. Now, so we know that it has to be somewhere in this area here. This value is going to be 0.2119. Of course, that represents the area under the curve, which is also the probability that the z-score or the value of z is greater than whatever this particular z value is. Of course, we're going to have to use our standard normal table, normal distribution table. And don't forget that this table only gives us the probabilities that are to the left of z. This table gives us the cumulative distribution values. So these are the values that are less than z. Well, if we just do subtraction, 1 minus 0.2119, we're going to get 0.7881. And so this is going to be the percentage or the value in the table that we're going to look for in order to figure out what that z value is. As you look at the table, you will see that 0.7881 is right there. And so the z-score that is associated with 0.7881 is going to be z is equal to 0.8. Problem B is asking us to find the z value so that the area between negative z and z is 0.9030. In other words, they want 90.3% of the data to be between negative z and z. Because I know the normal distribution is symmetrical, I know that z has to be positive and negative z has to be negative, or vice versa. But if one is positive, the other one has to be negative. And so your graph is going to look something like this. And we're trying to figure out, well, what is the z-score that's associated with this area under the curve? This is the same thing as saying find the probability that z is between negative z and z. In order to do this, we're familiar with continuous distributions, and we know that this would mean that that's going to be the probability that z is less than z minus the probability that z is less than a negative z. As you know, that this is just evaluating the cumulative distribution function at z and at negative z. You should recall also that the cumulative distribution function for the normal distribution is represented by phi. So what we're finding here is phi of z minus phi of negative z. You should also recall that phi of negative z is 1 minus phi of z. So this is phi minus 1 minus phi. Well, if I distribute my negative, I end up with a plus phi of z, so that gives me 2 phi of z's minus 1. You may have recalled this from one of my PowerPoint slides where I showed you that this is the case. At any rate, remember, we have to stay focused on our goal. Now that we know that this represents the area under the curve, we still have to figure out what that z is. So I know that this value here has to equal to 0.9030. Solving that for phi of z, I'm going to get 2 phi of z is equal to 1.9030. And when I divide both sides by 2, I get phi of z is equal to 0.9515. So remember, phi of z gives us the values in this table to the right, in our normal distribution table. So let's go to the table and decide or try to find where 0.9515 is. You will find it at 1.66. So the z-score that's affiliated with that is going to be z of 0.9515, 1.66.